Hey guys, what's up? Wayne Stevenson here. In this video, I decided I'd take the time to tell you guys how you can repair your damaged balance plug leads on your Lipo batteries. We got a Tattoo Fun Fly here, which I damaged this one in the field on its maiden flight, chopped off the balance plug connector in a bad way to avoid grounding out or that. I did a little field repair with rubber glove, and those were I believe pink post-it notes. That's all I could do. The whole thing was shattered. Just wanted to protect everything till I could get it home. It's been sitting on my shelf for months here. Today is gonna happen because I've already had to repin a whole bunch of these for my 3D printed CNC machine called the MP-CNC that I've built, and now I'm just cleaning up the wiring in that. So repinned a bunch of that. I figured, well, let's get this out of the way now. So I'm gonna open up this patient up and have a look at the injuries. The balance plug was completely gone. Wanted to keep everything separate. So as you can see, totally munched, all four of them. That connector just completely bsh. There's still sand in it from the hard landing. I was at a school. It was the long jump pit of all places that I ended up landing as well. I'm just going to start by individually taking these off one by one. I'm going to snip them. I'm going to repin them, or put a new connector, new pin on there, and then put a new connector on there, just to hold things all separately so that I can take my multimeter to it and find out where everything needs to be. So I'm going to keep these others insulated while I'm working on this one. Snip them one by one. You just want to snip just the ends off. I'm not taking much off because we still want some length here. Now the connector we're using is a JST type HX2.54. 2.54 is the pitch size. And, really tiny here. And you can get a case of these things off of probably Banggood, AliExpress, eBay. They come in a case, a whole bunch of various size connectors. Get some ones to go on your PCB if you're making your own circuit boards, and a whole bunch of pins there. These are probably $5 or $10 for a kit like that. Type of crimper you need for that one is an SN-01BM right there. I think it's really easy to do it. So, and the only thing to watch out, you will need one more thing, a wire stripper. Well, you can do whatever you want. The only thing to worry about here is not getting the length too long. You need just enough for the, that's probably perfect right there. You just need enough for the plastic, or sorry, the metal to grab it, and you want the insulation to be grabbed by the crimper. So that'll hold on to it. It's not going to hold on to the wire, like it'll crimp around the strands of your wire, but it's really held in place by the insulation. So when you're putting it in, what I do here, I don't know if you'll be able to see this easily, but I'm taking this, and you're using the biggest one here, depending on which model you get, but the teeth on here are meant for this. There's two different sizes, smaller, bigger. I'm using the bigger of the two on this one. And you're just going to get it in there and push it. I use the tip of my fingernail just to, you can use, tweezers just to push it in. This is what it looks like. go in the slot there, and it'll stay because it's got two little wings that are eventually gonna kind of curl in and grab that insulation. I like to give it a couple ratchet clips, then it holds it in place. It's not gonna fall out. And then from there, you just take your, lost another one I'll have to deal with. You just put it in there so that the insulation goes in just a little bit. So like I said, it's going to grab onto there, and you drive it home. Boom. That's all there is to it. Visualize it. Make sure that it's got that insulation. And like I said, I'm going to throw a connector on there just to hold it in place. Eventually we'll take our multimeter and make sure everything's in place the way it should be. Alright, we're on there. So, alright, let's back up a minute here and do a quick anatomy of these batteries. Hang on a sec. So you got your balance plug here. You got your pins here. Your red one's going to be your full voltage. So when you go onto the end one here and the red one here, you're going to get full voltage as if you were measuring it right from your connector right there. And then as it steps up from here to here, your voltage is going to go up. So the first one will show the voltage of one cell. It's going to add the second, third, fourth cell all the way up. So when you're trying to determine the pin order for a damaged one, you're going to do the same thing. So you're going to grab the your live one, your positive voltage, and you're going to check it with the pins on the other one, and that will determine what order based on the cell count. Grab this one here, and I'm going to check this one here. Oh, I'm going to put the wrong connector on. I put a 4-pin, not a 5-pin anyhow, so that's going to come out. Regardless, let's see if we can, there we go. Oh. 11.4, so that tells me that that's the third cell. If it was the fourth cell, it'd be showing the full voltage that we got off the main connector there. So that will be the third in the series. So I'll grab this one and I'll show you at the third cell in this series. I'm going to just lay this on the table here, and I'm going to go down the line. So I'm going to start from the red on the left, and I'm going to touch each cell so you can see what's going on. So I'm going to touch the first one in cell 4. Second one will double that up to 8, and we're going to get our 12, and then our 16.5 volts at the very end for our fourth cell. And that's how that works. So I'm going to go back to repairing this. So I'll put that back up here. Take my snips. Give it a little snippy snippy. We take our get my connector ready too, so I'll just throw that right in off the bat. Like I said, we stick our pin in and we kind of push it down all the way in. And then we, let's see if I can angle that so you can get a better look. Can you see that? Just goes in like that. You push it in enough so that once the insulation actually goes in there, because it's going to clamp onto the insulation. This is a little thicker wire than I usually use for these. And clamp, boom. Examine it, give it a nice pull, do the pull test, make sure it's clamped onto the insulation, which it is. So now we can put this in. And so you just want to make sure that you're sticking the pin in the right spot. So if you look at the balance plug, you got these keys here. So you want the keys safe the keys facing away from you. It's on the first pin to the right. Keys facing away, first pin to the right, and there's a little hook on here. That hook goes into those little holes there. That grabs that and keeps it from coming out. And there we go. First one is done. Well, it's probably because I'm using the thicker gauge wire for it. It's probably just tight. So I'll just throw that in. I don't know how the machines do this. Like, this is cumbersome. I'm sure they're done by machines, not by people. There we go. But you never know. You never know. Okay, get that in. It is tough too with these silicone wires. They're so flexible, which is why we like them. They make barely grabbed, but it did grab. Alright, so what do we say? That would be the third cell. And here we are, third cell. Boom, you are in. Alright. I'll just check what cell this is. .6. Now let's check what these other ones are while we're at it. 7.6. Curious. What we got going on here? Okay, that's that one. So let's tackle that. Get that out of the way. Boom. I do like to leave them insulated so that nothing shorts out while I'm doing this, but sometimes we take chances. So that's our last cell in the series. So throw that on. Give it a little curl if it's fraying on you a little bit. Get that in there, and boom. It's the final form of evolution. There we go. That's in. Right. And this will be our second cell in the series. As you can see, once you get in a groove, it really goes easy. Just like so. And take your time, and you can always snip it and redo it. Only so many times, because eventually you'll run out of room to work, but just remember to secure these when you're flying. I mean, that's the only real reason why they I catch. No, I didn't catch enough of the insulation, so I'll redo that, get rid of that. That's the thing, if you don't catch the insulation all the way, just rip it off. Rip it off. Or pull it off, I should say. So usually the wires will remain intact. It'll just slide right out, because there's not much holding it in terms of the wire itself. There we go. Like I said, that again, all right. That's not too bad, actually. That's in there all right. So I'll just use that. It's not holding enough that I like, but it's got a good grip on the wire itself. So I'm going to take a chance here. Now, if it don't go in, just give it a little prod with tip of a knife or something. Just push that in. Don't stab yourself. There. And the final one, and we are done. Right there. And we have a perfectly good connection. The only thing to do once we're done repair is run that multimeter over, make sure everything is in fact in the right location. It is easy to make that mistake. So again, we'll throw that in, make sure we get the insulation pushed in. That one went in nice. Boom, there we go, insulation's in there. Really good, and mission accomplished. Boom, it is done. So now we're going to run the multimeter over it just to confirm that everything is solid where we want it to be. So again, you can see that we have just copied over the same type here and same configuration, and we're going to confirm that we've got the right configuration because obviously all those wires are the same color. So we're going to put our positive lead tester on the first pin. We're going to go, and now the second pin, which is our first in the series. We're going to check the voltage, 3.8. We're going to step it up to the next one, 7.6, 11.4, and 15.25. And you can confirm here, the end here, the voltage is 15.25. Alright, so figured I'd show you how this looks like. So this is them there. That's the connectors there. This isn't a Lipo, this is for a stepper motor here, but I figured it'd be easier to show you than hanging a Lipo up in front of you. So those are the connectors. As you can see, it's got a kind of a barb there, a little fish hook. And I'll show you how they go in. So those little barbs, you can see it, just go in like so, and they'll click in a little bit, and that holds them in place. I'll show you 3 more times. Make sure that barb's in the right area, goes in, and clicks in. If you have any strands that have pushed there, just push them out of the way so they don't get in your way. And push it in, just like so. Boom. And like so. Oh, yeah, that's the right way. And like so. Boom, that's it. That is together. All there is to it. Well, I got it zoomed in, I can show you the crimper. Or I shouldn't say zoomed, well, I got it macro focused. You can see this. It's ratcheting. So it goes into here. You're going to push that in. So let's take one. Let's take a connector here and I'll show you. We'll waste one for the sake of your education. So goes like that. Now I will take it. You'll see that there's kind of 2 notches. It's kind of stepped down a little bit. One's down just a little bit more. So you want to put the wings to the side that there's a larger opening, so to speak. It's larger because that's the side that's going to take your insulation. Boom. So that's what it kind of looks like with it in, just like that. So that notch there, that's going to put the set the depth, kind of, right? So as you can see on the other side, that's the best way to show you. Yeah, so you can see how it's out there. So you're not crimping on any of that part because that's your little fish hook there. So you want to make sure that's all on the outside of your crimper. And it's crimp in 2 areas. One is going to crimp around your insulation, and it's going to crimp also on the smaller side around your wire. So let's just grab a wire. Alright, did I move my wire? Oh, I'm doing wiring downstairs, so I brought it there. So, alright. Don't recommend it, but whatever. Snip that as long, so I'm going to use my knife and cut it to length. You don't want it too long, so when it gets into the pin area that you don't want. So this is kind of the perfect length you want. Enough for the insulation to get into the fitting or the pin, and enough for that wire to go past into the other kind of half. And you can see here, this is what we're looking for. Alright, so we want to crimp the insulation and the wire on the other side of that line. And it just pushes in. I like to crimp it just a little bit, holds it in place so that when you push the wire in, if it's tight, it's not pushing out. So as you can see, it goes like, I don't know if you can see, my hands are in the way now too, so it just pushes in. Alright, you gotta see what I'm doing too. Just pushes in, and crimps, and boom. Now if it's crimping too much and bending the crap out of it, you can adjust your tension right there. And that's it. That is a beautiful crimp right there. Let's see. Back up. You can see how it crimps the wire as well as the insulation. It's crimped in two places. You don't want to put too much insulation in, and you don't want to put too much wire in, because then the wire will get out into here. So these connectors probably aren't that bad for it. Other connectors, not so much. Like DuPont, I've had issues with that. With, well, even with wire, you use the too thick wire. I mean, you can't use too thick wire on these ones. It won't go in properly, won't crimp properly. But DuPonts, I've had more problems with, based on wire gauge, anything, insulation as well. So hopefully this saves you from having to buy a new battery. If your battery hasn't shorted, or it's, hold on a second. There, welcome back. Hopefully this saves you from having to buy a new battery. You can repair it yourself. These connectors, they're cheap. For the price of a new battery, less than a price of a new battery, you can get yourself everything you need to crimp on new connectors. So keep that in mind. Thanks for watching. There you have it, guys. That is how you can replace your balance plug connectors for charging your battery if you've ever chopped them off. The best way to deal with those is to just secure them before flight. Sometimes we forget. I forgot. If you have ones that come with the little plastic protectors, use those. If you got a 3D printer, you can also, there's files out there that you can print for those as well. I probably should have done that too. In fact, I think these might have come with them, and I've always thrown them out. Like, more weight, I'll just tuck it in. Well, this is the maiden flight of that quad, maiden flight of this battery, and obviously I was in too much of a rush. I wasn't paying attention to the configuration. Luckily, didn't fry the battery or anything. I was able to get to it quick enough. It was a little bit of sparking, but it survived. So that's it. So once again, now things you're going to need. You're going to need JST connectors. They're the 2.54 pitch. That's the pitch that balance plugs use. You are going to need a good side cutter, wire snip. That'll snip it. You need a good pair of wire strippers, preferably. I mean, some people, especially with silicone, they can use their teeth, fingernail. These don't cost much. Don't use a knife. Don't use your wire snips to pull it off. Just get a wire friggin' stripper. And the most important part is your crimper. You can't really do anything with these without a crimper. These are like $20 Canadian. I think I've seen them for 15 bucks American sometimes. I get all my stuff off AliExpress. I can leave some links below if you want. It's a SN-01BM crimper. Love it. And you obviously want the HX2.54 crimper end for that. Again, I'll put information down below in the comments. If you have any questions, please leave them. Hope this video helps you out. Thank you for watching. Take care.